I'm going to talk about circuit breaker pattern and how we can monitor it, because monitoring of circuit breaker is very crucial part of using this pattern. I'm Ciołek, I'm CTO at Code Heroes. I'm Scala fan, and so far we have some projects using microservices. And the idea of the circuit breaker monitoring comes from my experience using microservices and integrations with external services. So, as in our architectures, you can see two types of communication. When we are using synchronous communication, we are forgetting right now about async, queues, etc. So we can have our own services, service A and service B, and we can have asynchronous communication between them. Or, for example, you can have some service C, which is communicating with external API. It can be a bank account API, it can be a transaction API, or it can be even a Facebook API for Facebook OAuth. The main problem with all of this pattern is that you're using external APIs and you don't always know what is the how they will look like, how they will work, what happens if there will be a huge load on them. So this is the most problematic part of using external integrations. And the most important problem you can see there, if this external APIs is some legacy system which using old asynchronous programming techniques, it is probably not able to serve as many loads as our application. So, when should we use it? We can imagine our system an external service, and when we are making one request per second to this external service, the latency can be lower than 100 milliseconds, so we are using this external service to deliver our job. What would happen when we, for example, make 1,000 requests per second, because we have many users on our side, and our domain we can't communicate with this external service asynchronously. We need to do it synchronously. So the problem is that latency can probably go higher. And more users, more requests, latency can go higher if the service is going to be unresponsive. The latency can go infinite, so your users who are clicking refresh on your pages, the pages is making more requests, we are making more requests to external service, and finally it crashed, and you can't do anything. That also happened with some external stuff. So, synchronous and API are widely used in modern software. The problem is that even if we are talking about these reactive patterns, asynchronous programming, there are a lot of great systems. For example, banking systems, card processing system, payment systems, which are still used synchronous technologies, and we can't rely on their APIs. So there is a common pattern which is called circuit breaker. So you can wrap your communication with circuit breaker, and the circuit breaker is responsible for it's a design pattern which detects failures and encapsulates logic of preventing a failure to occur constantly. So if the circuit breaker notices that there are some kind of failures, it calculates how many failures were happened within the period of time, and he decides that now there is a time to block the communication, and we can see it on the diagram. So the typical implementation of circuit breaker contains three states. When circuit breaker is in closed state, all requests are successful, but sometimes if there are some failure requests, and after, for example, three failure requests, the circuit breaker trips to open state. So then all the calls to the service are failing fast. So the calls to the external servers are stopped on the circuit breaker, and our users are just pushed out. Because if we decide that the service we are communicating to is not responsible, there is no it is not good practice to communicate it if you decide that it's not responsible. So we can block the communication on our side, not communicate to the external service. And for example, we can attempt to reset this blocking after, for example, 5 seconds. So we can give this external service, the time to back up to the
responsible state. And after this attempt reset, we can take one of the requests, push it, check if it was successful. If it was successful, we can come back to the closed state, or if it was not successful, we have another failure, we stay in the open state. Okay, we are on the ReactSphere and Scala conference, so there is a circuit breaker pattern, Akka pattern circuit breaker, but the problem that even in 2.4 version, it exposes only on open, on half open, and on closed callbacks, so we can only learn that there were some failures, some state changes, but to be honest, we do not have any monitor. The circuit breaker does not expose any extra metrics, which would be very helpful. In our case, we have a lot of integration with external systems, legacy systems. And when we decide to use the circuit breaker, because we need it, I am looking for some stuff which allow me to monitor them in real time. And I meet the issue that it would be great if Akka circuit breaker would provide some kind of metrics streams like the Netflix Hysterix. And of course, Netflix has a great Hysterix dashboard when you can, when they have a lot of commands, and for example, there is video metadata get episode, and they are collecting all the stats and metrics from these circuit breakers. And they can have a dashboard and monitor how does it look like and what are the current stats of the services. So I decided to implement the circuit breaker metrics, which will expose the reactive API. So I decided to do it with Akka Streams, and it can be done, and it is going to expose a source of raw events. So we'll be able to get all of the events and state changes and the status of calls through the circuit breaker with this source, a source of buckets, time average. So we can set up the time period. We'll collect within this time interval the metrics and push these buckets. And in the future, I would like to implement a source of buckets, time histograms, so we'll be able to know how many percentage of requests were completed within some kind of time. Okay, so let's take a look at demo. So, there is a piece of code. As I said, there is a circuit breaker pattern in Akka. Have you used it before? Who has used it before? Well, maybe you are not integrating and you don't have problems like we, but okay, this circuit breaker is taking a couple of parameters. It's a scheduler for scheduling these timeouts. Max failures, so it means how many failures, how many calls we are going to push through the circuit breaker, and if there will be constantly, for example, 3 calls, we are changing the state of circuit breaker to opened, and the open state means that we are blocking all the further calls. And there is a call timeout, so a circuit breaker is measuring how long the call takes. If the time of the call is going to be larger than the configured call timeout, we will calculate it as the failure. We will fade this request and also increase our current failures, which will result, of course, in open state. So to sum up, it means that we are monitoring how long the request takes, and if it takes, for example, too long, we are just stopping it. We will fail it fast and calculate it as a failure. And we have a reset timeout. So this is the time when the circuit breaker is in the open state, and after the configure reset timeout, we are going to change it to half open state and take the first request which will come to us, and we are trying to push it to the service. And when we get the success response, we are changing the state of the circuit breaker to closed, and if it fails, we are coming back to the open state and we are retrying one more time. Okay, so we have a simple application, and we have some kind of implementation of chaotic service. This service is really simple. It just do the job and returns the future of done, and we are randomize the next value of 1000, and
about 90% of the requests we are going to have a success response, about 5% we would like to just fail, and on the other 5% of requests we are going to have be delayed by 5 seconds. So this is just an example in order to test the solution and just to mock up some kind of external service behavior. So we can say that we have a service which in 90% works great. There is a 5% for failures, and there is a 5% of requests which will result in longer time of processing. Okay, and well, okay. So we have a service. We have a circuit breaker which we are using to protect the service, and we have this metrics when I will describe in a couple of seconds. So what we are going to do, we have this breaker, and we are exposing an HTTP API from our application. So when there will be a post on a jobs, we are going to, normally if you will not use the circuit breaker, you will just do something like this. So just push the call from the HTTP to the service and waiting for something, what will happen. If you are using the breaker, you are using this breaker and call with circuit breaker, and you are just pasting here your code. So it means that all calls will be wrapped by the circuit breaker. So it's really easy API to use it as breaker. The configuration, as I said, is really easy because you are just putting some kind of a couple of parameters. And that's it. Another things about the talk is about this is the circuit breaker metrics. I have a pull request pending to Akka. Maybe Akka core team will review it soon. And right now we have two methods from the circuit breaker metrics which expose the API for monitoring what is going on within the circuit breaker. So we can just have a source of raw event, and when we take a look on the event, we can have I have enhanced the implementation of circuit breaker, so now I am able to get more info from circuit breaker. So we have event like call success within a and it was and within a time. I have a call failure, I'll have call timeout, I have call breaker open, which means that requests were rejected because they were received by circuit breaker when it was in open state, so when the circuit breaker decided to block all the stuff. And of course I have a simple events for the state transition of circuit breaker, so breaker open, breaker closed, and breaker half open. So this is the simple events flow, source of events from the circuit breaker, and it requires a breaker which will be monitored. We need to have a buffer size because circuit breaker is not reactive, so we need to buffer this stuff. This is the problem that it was taught at the first talk today, that we will be reactive if all the part of the system will be reactive, but if we are using synchronous API to communicate, our circuit breaker is also synchronous in this way, so we need to have this buffer size to buffer the events if there is no demand from downstream. And this is overflow strategy, so what we should do if there will be too much events in the buffer. So this is raw stuff and can be used somewhere. And another API is time buckets. So we can provide a breaker, and we are setting up the interval of the buckets. So we will be collecting the events within, for example, 1 second. We'll calculate these buckets and push it to the downstream. And there is also a buffer size for this bucket. So how many buckets we would like to keep in our buffers. And if you can then take a look on the time bucket results, we have the start of the time bucket, the stop of time bucket, the events of breaker opens, the event of breaker closed, half opens, and here we have time buckets for each of situation where call success, call failures, call timeouts, and call breaker opens. And in time bucket, we are calculating the sum of elapsed time and the count. So if we receive 100 success responses, we'll just calculate it in the success responses. Okay, and it is really easy to use this metrics because we just creating our circuit breaker metrics with time bucket methods, and we have here a source of time bucket results. And what is great, this is a raw Akka Stream API, so we can push our data through everything which we have from Akka Streams and all of known libraries which support Akka Streams. In our case, I have used a WebSocket, so I will be able to push all of this time backends to the web browser, for example, and draw some statistics. The API of WebSocket is really easy. We just, in this example, we are going only to have the WebSocket which is pushing the data to the user. So we can use another method of establishing the WebSocket connection. We just taking some upgrade to WebSocket header, and then we are just using a method handle messages with sync source. The sync for messages from website will be sync ignore because we want to ignore the data from the website. And the source will be the stat source. And the stat source is just our metrics, which is serialized to JSON, and then it is mapped to text. And that's all. Okay, and finally I'm setting up just a Akka HTTP server, bind and handle requests, and the route. So our application is a simple application which is making a jobs with some kind of external service, which is a chaotic service in our case, and it also is exposing the statistics of the circuit breaker to the world. So this is the implementation of our app, and I have implemented the load test using Gatling. So this is the simulation written in Gatling. So we have some HTTP conf. We have a scenario when we are repeating 1,000 times an execution of posting just the jobs. So every user will repeat 1,000 times a request post jobs, and then it will wait 200 milliseconds and repeat one more time. And we are setting up our scenario. We are ejecting the user. At the beginning, we have 10 users, and we are ramping up our users to 500 within 60 seconds. So what I am going to do right now is to, okay, I have some web application here. I am going to start SBT for running my application, and we can start SBT for running these tests. Okay, when I start my application, okay, we can go to Chrome, and we can see that we have, I'm also not good at UX, so I use just some Bootstrap stuff. So right now there is no calls to our services. We have a total calls count, so we will have the chart of the calls count we have done within 1 second. We have average success failure latency, so we will calculate how much time does it take to process the calls through the circuit breaker. And here we'll be have the events of how the status of the circuit breaker changed. So the next step is to run our simulation. So I'm starting the test. Okay, and we should see. The green is the success request, the red is the failure request. So right now it's okay, we are making about 300 requests per second for 500. Here we have average responses. We can see that success are faster than. Oh, and we can notice right now that there was some that our circuit breaker goes into open state, so it blocks all the requests. We can notice that all the requests are blocked, so it means that our circuit breaker is in open state. And after a couple of reset interval, we can see the event that the circuit breaker, the yellow one is that the circuit breaker was in half state, and the green is that the circuit breaker came back to the open state. And this is our simulation. We just show that we can monitor it easily with this API, and we can expose the statistics with just the few lines of code to our dashboard, etc. So right now we can notice that our breaker breaks all the stuff. After a configured reset interval, we can see that we can process some requests, but there were some failures, and we just going one more time and one more time. Of course, it's a really bad situation if it occurs in our system. This should never look like that. We should always have a green line, but in our case, our chaotic services work as it is. So, do you have any questions to the API or the code? No? Okay. So, let's back to the presentation. As I have shown you in the seconds, it is really easy to use this metrics, and I really recommend to use it in your application, because in many times, if you are using, for example, Akka HTTP, you get some 500 error, server internal error, and you don't know what was happened. And basically, it can be the problem of integration with some external service. If you protect it with the circuit breaker and you collect all these metrics and expose it to some kind of dashboard, you are happy and you can monitor what is going on. And what is really great, you have a tool to monitor what is going on in the integration with you and the third-party services. So it's really important to use it. If you don't know this pattern before, I really recommend it to start using it, because Akka has a great implementation and very fast of the circuit breaker, and I hope that the circuit breaker metrics will be soon available in Akka also. Okay, I have implemented Akka Streams, so metrics can be exposed using Akka Streams, and we can expose it with WebSocket. We can, for example, push all these metrics to Kafka and use this metrics somewhere else with a reactive Kafka implementation. We can use some extensions from Alpaca, for example, servers and events, etc. So it's really great that it is just a source of event, and developer can decide what can and how can we process these metrics and decide what to do. And some example how can you use it. This metrics. So suppose that this is our application, and we have 3 types of requests to external service. So we have request type 1, request type 2, and request type 3. In the first request, for example, we are getting users from external service. In the second request, we are creating user, and in the third request, we are, I don't know, finding user by first name. We can have three separate circuit breakers on each of them. And then we can expose the metrics, map this metrics with some tag functions, so we can tag each of metrics from a specific request type. We can then merge it and push it, for example, to Kafka sync. And at the end of the Kafka, when we are reading from Kafka, we can learn and collect all the metrics from our one application. So we have one application with three circuit breakers. We can expose the metrics, merge them, and push with the one sync. Another idea is how you can use it at scale. The problem of Hysterix is that if you would like to use Hysterix and these metrics, they have only integration for servants and events, as far as I remember, and they have a special Turbine, another project which is collecting all these metrics, aggregate and exposes it with the dashboard. And in this case, you can use all of these components. And for example, in your microservices architecture, you have service A, service B, and service C. And all of them can be a Docker containers and can expose these metrics. And there can be, for example, a service which is called metric aggregator service, and he's reading all of these metrics from the services, aggregating them, collecting, and just exposing it with some kind of dashboard. So it's a very flexible solution. So why you should use it? You should, of course, protect your system against cascading failures. So it means that if there is a failure in external service, you should stop and respond with failure as fast as you can do it. So circuit breaker allows it to do it. You can monitor these failures and react in real time. It is really important that if you have, for example, integration with some card payment processor, and you need to and your system relies on card payments, you need to monitor this integration with external party service in order to decide and see what is going on.
It is done with Akka Streams, so it is reactive processing for free after we just buffer some stuff from the circuit breaker, and we can expose this data as you want with all Akka Streams integration, and so far there are a lot of integration we can use. So it was really fast and goes much faster than I thought, so thank you very much. If you have any questions, just ask me. No questions? Who is using some external integration in your system? Do you using this? Yes. Do you use a circuit breaker or not? It would be great if you can start. Okay, so I hope I can share the code on GitHub. If you have some question, I am here today, and I am also available tomorrow on this speaker session. So we can talk about circuit breakers and all these problems in monitoring stuff in your system. So thank you very much.